Hey guys, Mr. Riz here to help you out with the first section of chapter 2. So hopefully you guys are watching this video if you guys are ever struggling or if you're absent, keeping up with these things. So in 2.1, we're going to be looking at what are known as relations and functions. And so our goal is to be able to graph relations and identify whether they are functions. So first off, let's talk about this one. A set of pairs of input and output values, that is called a relation. So that's a vocab word for us. We're going to have an input and output value. All right, so you can represent four or relations in four ways. First off, we can have them as input, output, or as points on a graph. All right, or we can have them here looking as, sometimes people call these ones clouds or other types. We have an input and output pair or cloud that we're looking at. You can also see them as tables, your X and Y tables, or you can have it visually as a graph. So if you look at all these, you have the same four data sets, but just visually graphed out. All right, so the relation can be broken down to two key parts. The domain of a relation is the set of all the inputs or the X values. Okay, so in this problem here, the domain, which I'll just say D, would be like -3, +3, and +4. The range is all the outputs or the Y's in the order pair. So the ranges here would be 4, -1, and 3. Now we probably could want to put these numerical value, but it makes sense. All right. So now specifically, if we're looking, a function is a relation where the domain or the X values correspond to every single or to exactly one element in the Y range. So if we look at this one here, these are not functions. And if you look to see here, every single time we have our X number 4 going to two different numbers, this X number 4 going to two different numbers, this X number 4 going to two different numbers. Even here on this graph, we have an X that goes to two different numbers. Okay, so what we're going to do first is we're going to look at these graphs here, or these different relations, and determine whether they are functions. So let's state the domain. We'll do the brackets. The domain are all the X's. So we got -1, 0, 4, and 6. And then our range would be all the Y's. We got -9, -5, -2, and 3. I'm putting these in ascending order. Now, is this a range? Do we have any X's that repeat? We do not have any repeating X's, so it is a function. All right, if you guys want to pause the video, try this next one on your own, you can. I'm about to do it in just a second here. All right, the domain for this one here, we got -3, then 5 and 8. Those are all our X's. Our Y's, we got lowest is -6, then we got 0, then we got 2, and then we got 4. Is this a function? No, because if you look, we have these X's here, they repeat, and they're going to different numbers. All right, next, if we got it as a table here, all right, we can see here, this is nice. We got -4, 0, 2, and 7 are X's, so there's our domain. Our range, we got -1, or no, -8 is actually lower, then -1, and then +3. All right, is this a function? Yes, it is. Now, even though we have Y's that repeat, that's okay. We just cannot have X's that repeat. And last one here, let's see, our domains. Well, that's kind of nice. It's already in the bubble for us. We got -4, -2, and +5. And then our range is the Y bubble here, 0, 3, 7, and 9. Is this a function? No, we have this X going to two different numbers. So basically, you can use the X variable to determine whether a relation is a function, or we can use what's known as the vertical line test. All right, so that might actually be a better one to do. So the vertical line test is what we're going to look at next on a graph. Vertical line test. That would make sense because there's 3 blanks here. The vertical line test is when we look at the graph and we see if there's ever more than one point of the graph that is touching a vertical line. If there ever is, that fails the vertical line test, and that is not a function. So if we look at this graph here, if we have this function here, this one fails the vertical line test because if we have a vertical line here, or really anywhere kind of before, it's touching more than one point. So what you always want to do, I always like to run my finger across to see if there's ever a time that it's touching more than one point. This first one here, we could draw a vertical line here and it's touching more than one point of the circle. So that fails. No. Now, even though that this is not a line, do we have any time a vertical line would touch more than one dot? It passes the test, it's good to go. Same thing here. I know it goes up and down, but if we have vertical lines going all the way across, it would never touch more than one spot. So that one passes. So now that we know what kind of relations are functions, we can talk about how we can use a function. All right, so a function rule is an equation that represents an output value in terms of the input value. Usually we see these as, x's and y's. All right, you can write a function rule in 3 different ways. All right. We can usually put it as our x and y. You can also see it as a function of x. But the thing to remember is that the function of a number is just replacing that x. All right, so what we're going to do now is to see, like, if we know that this is a function, we can find the predicted outputted value based on the input. So if we have a function where f of x is equal to -4x plus 1, we want to find the output value given that x is -2, our input is -2, we're just going to replace our x with the -2. All right, and so what's -4 times -2? Well, that's +8. 8 plus 1 is 9. Now, if we have a different input value, we probably have a different output. Let's check that out. So what's -4 times 0 plus 1? Well, that'd be whatever 0 plus 1 is. That'd be 1. If you want to try this one on your own, okay, what would be the value if we have 5? We're going to plug in 5 in for x. -4 times 5 is -20. We add that to +1, that's -19. So once we have functions, we can take the independent variable, our x, and plug it in and evaluate the dependent variable, which is our y or f of x. Okay. Now all this can be translated then to real world problems here. So we can write a function model to represent this value here. So say we have a monthly service fee of $4.52 and the rate is 0.12 per minute and we have 150. What we want to do here is to realize that we have a function here and that we would have a total rate of 12 cents per minute. So X could represent the minutes. All right, and then our total here is our f of x. So what we can do here is our 250 is our input number. And we're going to go through and really, another way to think of this is we're going to take the equation, the function, and we're going to plug in 250 into the equation. And then our output is going to be our total value. All right, I might need to grab a calculator here. It's kind of early, so I think I'm going to do that. 0.12 times 250. Try to do it in my head before I get started here. Let's see, I know that'd be 25 plus 2% of 250, which is probably 5. So I think it's 30, but let's see, 250 times 0.12. It is 30. And then plus 452. Well, that's easy. That's 3452 is our total. Okay, so this is going to wrap up our notes here. So you have your practice problems. Remember, this are the CYU problems that you guys will do online. So just first determine whether these are functions. So look to see if the x is repeated all, and then name the domain and range. And then one problem here, just making sure you can evaluate a function or use function notation. All right, guys, have a good one, and I will see you for the next lesson.